Hi. Good morning, everyone. We're Team 970, and our project is titled Reducing Input Total Harmonic Distortion in an Uninterruptible Power Supply. At this point, I'd like to introduce our EE majors. So my name is Wonjung Zhu. This is Kevin Chai, Daniel Arndt, Toby Kukarkans, and at the end is Raul Favela, and our CE major, David Park. So we are designing an improved UPS control system on the AC-DC converter side to reduce input current THD. And we're going to do that in MATLAB and PSIM software. So now Kevin will go over some of the performance metrics as well as the system that we're currently working with.
All right, so for the performance metrics, the first one we're concerned about is THD, which we want the input current THD to be 3 to 5%, which is the ratio of the harmonic distortion relative to the fundamental frequency. In our case, the fundamental frequency will be our input sinusoid, which is a constant frequency of about 60 or 50 hertz, which is the AC mains. And we want a displacement power factor of greater than 0.97, which is incorporates the THD and the phase offset of the input current and input voltage. And we will be using PSIM and MATLAB to perform frequency analysis to calculate our input current THD. And the current system we're looking at is like a double conversion UPS system. And it incorporates a PI controller for the outer voltage loop and a proportional controller for the inner current loop. And we're looking at a cascade control loop system. And currently the system has about 30% THD, and our PSIM and MATLAB shows about 27% THD. And so Juan will continue to talk about our approach and solution to reducing THD.
Yeah, so as far as the solutions we came up in this semester, we are to implement a proportional resonant controller, which we expect to perform much better than the proportional or just a proportional integral controller. Because basically it introduces infinite gain at a fixed frequency, and that is the most ideal for sinusoidal tracking. In addition to PR controller, we are to implement harmonic compensators, which allows us to target and eliminate specific harmonics. So you can see on that picture, we're going to target third and the fifth harmonic first. And that would greatly reduce our total harmonic distortion and get our power factor as close to 1 as possible. So transitioning into Senior Design 2, we will implement PR controller and harmonic compensator in order to meet our desired specification improvements. So thank you for your time. At this point, if you guys have any questions, we'll answer them.
Yeah, what would happen if you had a surge? A lot of times you have a lightning strike, electrical lines surge up in voltage,
Right.
and they take out all your electronics that are hooked up to your UPS. And that's one of the main reasons you're using a UPS in the first place. And regular UPS systems have a problem with that too. Number one, does yours do an AC to DC conversion all the time?
Yes, it is a double conversion system. So it always converts from the mains AC to DC and then DC to AC.
Well, good. So I mean, that means it probably sacrificed the front end in a lightning strike, but it might save the rest. But anyway, any UPS system needs some good lightning protection in the front end.
Toshiba hasn't really explained any of that to us, so
Yeah.
I can't really comment on that, but I understand.
So what type of filtering are you using in here, or what are you proposing to use?
So the filters here are, these two are the same filters. It's just an LC filter mostly to block out the switching frequencies.
For the scope of our project, we're not really changing any of the filters or any of the hardware design. We're only concerned about the control system.
So how do you plan to implement this full system? I mean, do you plan to put the whole hardware on a board, or?
It's currently implemented on an FPGA board, and
Just the controller?
yeah, it's the controller.
Or you plan to You plan to do the controller only?
Yeah.
Okay.
All right, let's thank the team.